I'm going to find the dot product of the vectors u, which is equals to I plus 2j plus 3k, and the vector v, which is equals to 4i plus 5j plus 6k. So for me to find the dot product, I'll click on the return key, and then go on and click on quote. So the first step is to enter these vectors. So I will enter the first vector there, the u is equals to, then we open the brackets there, then we enter the components there of the u, the 1, 2, and 3. So I'll put on the 1, 2, then 3. I'm entering this as a row vector. So I can go on and click the return key, then enter vector v, which is equals to, then open brackets, then enter those numbers here, 4, 5, 6. So the components there, 4, then 5, then 6. So when we enter them like these ones here, we are entering it as a row vector. So you go on and run. So we have our row vectors there, u is equals to 1, 2, 3, v is equals to 4, 5, 6. Then I will go on and click on the return key. Now to evaluate the dot product, the u dot v, I can call my solution s. So s is equals to, then we will now need to use the command dot, then open parenthesis. So for the dot product, we are taking the dot product of u and v, so it's u, comma, v. And I'll go on and run. And we have the dot product there is 32, which is obtained by multiplying the corresponding elements and then adding them. So that's the dot product there. So in this case, when you are using this command dot, the vectors that you should enter should have the same dimension. So for example, I entered this as a row vector, the u. So the v again was supposed to be entered as a row vector, but you can also enter them as column vectors. So I can just change, just to illustrate, I'll put a semicolon, then put a semicolon here, then put a semicolon, and then put a semicolon. So what I am doing here, I'm changing the vectors here to be column vectors. I can just run, and you see that our u here is now a column vector 1, 2, 3. V is a column vector 4, 5, 6. So I've just rewritten the vectors in a different way, but our solution doesn't change as long as the vectors have the same dimension there. So our s, which is the dot product, is equals to 32. So that's our solution there.